Good morning, everyone. And today's topic is from Model 6, which is image classification with AutoML. So, here the core concept is why AutoML for image classification? Why do you want to use it? Image classification is a core computer vision task, but building a model manually is a complex and resource intensive. And manual pipeline challenges or like data preprocessing, model selection, hyperparameter tuning, and feature engineering. And in the data pre-processing requires expertise in image augmentation, normalization, and handling varying sizes. In the model selection, choosing between CNNs, example RESTnet, EfficientNet, VITs, vision transformers, and their variants in non-trivials. Hyperparameter tuning, a vast search space for learning rates and optimizes batch sizes, etc. In the feature engineering, like in deep learning, this is largely handled by the model, but initial architecture choice is critical. And in the AutoML roles, AutoML automates this end-to-end process, making it accessible and efficient. It systematically searches for the best combination of data pre-processing and model architecture, as well as the hyperparameters. How AutoML applies its taxonomy to image classifications, particularly. In this image classification, like so you can referencing the AutoML taxonomy, we can see how it structures the automation for images. So example, AutoML components, it is classified into three things like AutoML components, applications in image classifications, and also the examples for the same. So we'll go through it. Data preparation. In the data preparation, the application side, automated image augmentation, resizing, and normalization happens. And in example or AutoML might test random rotations, flips, or contrast changes to improve model robustness. Feature engineering, automated extraction of features using learned embeddings from pre-trained networks or neural architecture search NAS. Using a pre-trained CNN as a feature extractor or using NAS to find a novel cell structure. In the model selection, searching across a defined search space of model architectures, and example is like evaluating performances of RESTnet 50, MobileNet V2, and a vision transformers. Hyperparameter optimization (HPO), tuning parameters specific to the chosen model and task. Using Bayesian optimization to find the optimal learning rate, batch size, and dropout rate. A practical demonstration of product defect detection. So, for the product defect detection, so product defect detection can happen normally in the manufacturing factories, like manufacturing companies, large factories, where the manufacturing company needs to automatically classify products from a conveyor belt as a defective or non-defective. So that is very critical for their business, which will be which will improvise their production as well as the fault finding or defect finding in their product line, in the production line. AutoML workflows or data ingestion and validation where upload a labeled data set of images. Example, you can have thousands of images of good and defective items. The AutoML system automatically splits the data into training, validation, and test sets. So normally when we do it, it is a tedious process. And when AutoML does automatically, it does the processes like training, validation, and test, and automated pipeline searches like data augmentation, architecture search, and hyperparameter tuning happens. Like in the data augmentation, the system automatically generates augmented images, rotation, zooms, brightness adjustments to increase data diversity, Architecture searches the system experiments with different CNN backbones. Example comparing efficient net B0 versus REST-NET 34 to find the best feature extractor for this specific dataset. Hyperparameter tuning, it is simultaneously tunes the hyperparameters for the top performing architectures. And model training and evaluation, the best found pipelines is trained on the full training data. The final model is evaluated on the held out test set with metrics like accuracy, precision, recall, and FN score reported. Deployment, the AutoML system exports the model in a standard format, example ONNX, TensorFlow, saved model for deployment on the factory edge device or server. Popular AutoML frameworks for image classification or like Google Cloud AutoML Vision. It's a user-friendly one and requires minimal ML expertise. And Azure Custom Vision, similar to GCP offering, good for rapid prototyping. That's one advantage of the Azure Custom Vision. And NVIDIA TAO toolkit, it leverages transfer learning and is optimized for NVIDIA hardware and autokeros and open source options that provides a keros like interface for AutoML. So that's all about the image classifications in AutoML. And next one is recognizing handwritten digits. For this, the problem and why AutoML is to be used for this particular task, like problem definition, what it is. Like when you go for the handwritten recognition, um, text recognition. The task is to correctly classify images of handwritten digits 0 to 9 into their respective classes. It is often the hello world for computer vision kind of one. And challenges in the manual approaches are like pre-processing, model selection, hyperparameter tuning, and reproducibility and standardization. So these are the challenges in manual approach. So we are going to overcome all these manual approach challenges. Like in pre-processing, you may face what may size to use, normalization and binarization. And model selection should be use a simple logistic regression, a traditional ML model like a SPM, a simple CNN, or a complex pre-trained network. Hyperparameter tuning, optimizing learning rate, number of layers, filters in CNN, etc. is time consuming. Reproducibility and standardization, ensuring a consistent process for model development and evaluation. AutoML's value proposition. AutoML provides a systematic reproducibility and often more efficient framework to find a high performing model by automating the above challenges. So these are the things which we are going to overcome by applying the AutoML taxonomy to digit recognition. So what we will be having the specific problems. So AutoML components like in the data preparation, we may have automates the pre-processing of image data. The practical example is the system might automatically standardize all images to 28 by 28 pixels, normalize pixels values to 0 to 1, and apply augmentations like slide rotation or zooms to improve generalization. And feature engineering can automatically derive relevant features, and example is by the CNNs learn their own features. An AutoML tool might also experiment with extracting handcrafted features, example hog, Zernike movements for simpler base models in its search space. And model selection cache problems searches for the best algorithm and architecture. The system might evaluate a range of models from a k nearest neighbor KNN, KNN classifiers to support vector mechanism SVM to various convolutional neural network CNN architectures. And for hyperparameter optimization, HPO finds the optimal settings for chosen model. And example is for a KNN model, it is It turns n neighbors for a CNN. It searches for the best learning rate, number of filters, optimizers, Adams versus say SGD, and dropout rate. And next is practical demonstration of the same on the an AutoML workflow on minced dataset using the famous minced dataset as a case study. Like we are going to have a practical demonstration on the same. Like in the problem setup, step one, it is a step one. That is a problem setup. In input 2 cross 2 or 28 cross 28 by 28 pixel grayscales images of digits, and output should be like a single integer label 0 to 9. Matrix is classification accuracy. So in the step two, like AutoML process in action, data ingestion and splitting, the AutoML system ingests the minced data and automatically creates training, validation, and test splits. Search space definition, algorithms, logistic regression, random forest, simple CNN, SVM. And preprocessors like a standard scaler, normalizers, HPO space for CNN, learning underscore rate of log scale, 1e minus 4 to 1e minus 2. That is num conversion layer 1 comma 3. Parallel exploration and evaluation, like AutoML systems, uses a search strategy, example Bayesian optimization, to propose different pipeline configurations. It trains and evaluates these pipelines in parallel, example on a GPU clusters. The example search paths are like trial 1, SVM with kernel equal to RBF, that is C equal to 1.0, accuracy is 98.1. And trial 2 is simple CNN 2 layers with learning rate equal to 0.001, accuracy is 99.2%. Trial 3 is random forest with n estimators equal to 100, and accuracy equal is 96.7%. And next is the model selection and final training. After the search budget is exhausted, the best performing pipeline, example the specific CNN configuration from trial 2, is selected. This final model is retrained on the combined training and validation data. Step 3, deployment. The trained model is serialized and can be deployed as a REST API to classify new handwritten digits submitted by users. In as so So that's it from the reading habit and yeah. Next is text classification with AutoML. In in the core concepts like pervasiveness of text classification. Text classification uh, is a fundamental NLP tasks with widespread applications. Uh, so, sentiment analysis, topic labeling, spam detector, intent classification. These are the well-known test classification fundamental NLP tasks, widespread applications. Like say, what is happening in the sentiment analysis? Like classifying product reviews or social media posts as positive, negative, or neutral, and topic labeling, categorizing news articles into topics like sports, politics, or technology. Spam detector, identifying and filtering out spam emails or messages. Intent classification, powering chatbots by classifying user queries into intents like book, flight, or check balances. And next is challenges in manual pipelines for this particular implementation, and text pre-processing, deciding on tokenization and stemming lamentation, stop word removal, etc. Feature engineering, choosing the right text representation, example bag of words, TF, IDF, word to vector, and word embeddings. Model selection, selecting from a wide range of algorithms, naive Bayes and SVM, LSTMs, or transformers. Hyperparameter tuning, optimizing parameters for both the feature engineering and model selection steps. AutoML's roles. AutoML automates this complex decision-making process, systematically searching for the optimal combination of pre-processing, feature engineering, and model selection, applying the AutoML taxonomy to text classification, So in this, or we'll go through the AUTOML components like we did in the previous thing. So data pre-processing, preparation like automated text cleaning and pre-processing. And next is a practical example like system might experiment with different strategies applying lemmatization versus keeping raw tokens, removing stop words versus keeping them. Feature engineering like automated feature extraction and selection from text. And next is the example or search space includes different features extraction methods, bag of words, BOW, TF-IDF, the pre-trained word embedding, GLOVE model, or context-aware embedding for from transformer model BERT. And model selection cache problems searches for the best algorithm for the task. The system evaluates a diverse set of models from traditional naive Bayes and linear SVM to complex recurrent neural networks (LSTMs) and fine-tuned transformer models. Hyperparameter optimization (HPO) tunes the parameters for both the features extractor and the model. For TF, IDF, and SVM, tunes ngram underscore range, max features, and SVM's C parameter for a transformers tunes learning rate, number of training epochs, and batch sizes. Practical demonstration, customer support ticket routing. This is so, for example, the problem is an IT company needs to automatically route incoming customer support emails to a correct report. Examples we take here are billing, technical support, sales. So automable workflows or like data ingestion, input a historical data set of support tickets with their text and assigned department labels. Automated pipeline search, pre-processing and feature engineering. The automable system tests various text representations in parallel. Pipeline A, TF, IDF with 1,2 engrams, and pipeline B, pre-trained GLOW B word embedding, and pipeline C using pre-trained BERT model to generate sentence encoding. And model selection and HPO for each feature types. It tests and tunes different classifiers for pipeline A, TF, IDF, like it might tune a logistic regression or SVM model. For pipeline B and C embeddings, it might tune a simpler classifier like neural network or even another logistic regression model on the top of the embeddings. Evaluation and selection or all pipelines are evaluated on a validation set using metrics like accuracy and FN score. And best performing pipelines, example BERT encoding plus a tuned classifier, is selected. And deployment, a final model is deployed as an API. New support tickets are automatically classified, and the result is sent to the company's ticketing system for routing. A popular AUTOML framework for text classifications like Google Cloud AUTOML Natural Language, a user-friendly, high-performance platform that requires minimal coding, and Hugging Face AutoTrain leverages state-of-the-art transformer models for the Hugging Face ecosystem, ideal for developers familiar with the libraries. AutoKeras text classifiers and a open source option that provides a Keras-like interface for deep learning-based text classifications, and Teapot, that is tree-based pipeline optimizer tools, and open source tools that can automate traditional uh, ML pipelines, including TF, ITF, and classical models. So these are the in class discussion. We can discuss about the backlog problem and bias, fairness, etc. These are the further reading and assignments. So that's all about the text classification and new group topic classification with AutoML. It's a last topic in the unit. The core concept problem definition automatically assign one or more topic labels to post for online discussion forum like Newsgroups. This is a classic NLP problem, often using the 20 Newsgroup dataset. Key characteristics are multi-class classification, high dimensional sparse data, noisy text. So, multi-class classification, each post typically belongs to one primary or topic, example, rec, sport, baseball, sci, space, graphics. High dimensional sparse data like text data naturally creates a very large feature space, vocabulary of thousands of words, Noisy text posts often contain email headers, signature quotations, and informal languages. Why AutoML? Why do we choose AutoML for this particular thing? Manually testing all combinations of text pre-processing techniques, feature extraction methods, and classifiers is infeasible. AutoML provides a systematic way to find the best text pre-processing strategy, select the most effective feature representation, and identify the top performing model architecture and its hyperparameter. These are very important when we do a manually combination of text pre-processing techniques. So applying the AutoML taxonomy to a news group classification, in this AutoML components, data preparation, and application in news group classification like automated text cleaning and normalization. And practical example is system test strategies like lower casing, removing punctuation numbers, stripping email headers, and handling special characters. Feature engineering like automated conversion of raw text into numerical features. The search space include bag of words, BOW, TF-IDF, n-gram models, unigrams or bigrams, and modern word embedding like word to vector and fast text. Model selection such as for the best classification algorithms. The system evaluation, naive-based, efficient for text, support vector machines, historical SOTA for this, and random forest and neural networks for the examples. And hyperparameter optimization ITU optimizes parameters for both features extraction and the models. For TF-IDF tunes max underscore feature, comma, in grams underscore range, and minimum underscore TF. Like for SVM tunes C and kernel gamma, etc. And the practical demonstration we'll see in AutoML workflow for the newsgroup classification. Problem setup: input raw text from the newsgroup posts, output topic labels, example sci.med, talk.politics.middle east, metric classification accuracy or effort score, automobile process in action like search space definition, preprocessor, keep header, remove header or stemming lamentation, feature extraction, TF, IDF, word to vector, word embeddings, models, multi-nominal, naive base, linear, SVM, logistic regression, random forest, etc. And HPO space for TF, IDF plus SVM, C of 0.1, comma 10, kernel linear, comma RPF, max features of 1000, comma 5000. This is a command for this. And a parallel exploration evaluation AutoML system uses a search strategy, example Bayesian optimization, to propose different pipeline configuration. It trains and evaluates these pipelines in parallel. Example search path like trial one TF-IDF by TF-IDF method max underscore feature is equal to 5000. We are setting as a max feature. Naive bias is accuracy 85%. Trial to word to vector plus logistic regression. Accuracy is set to 82%. Try 3 is TF-IDF n-gram principal range 1, comma 2, linear plus linear SVM, C is equal to 1.0, and accuracy is 89%. And trial 4 is put embedding plus linear SVM, accuracy is set as 91%. Model selection and final training after the search budget is exhausted. The best performing pipeline example, BERT plus linear SVM is selected. The final model is retrained on the full training dataset. Step 3 is deployment and monitoring. The model can be deployed to automatically categorize new posts in real time. Performance is monitored over time to detect concept drift, example news lag, new slang, or topics emerging. In-class discussion points and activities in think, pass, share, ethics discussion, hands-on activity. These are the points that can be discussed for further understanding and advanced concept beyond basic classifications like multi-level classification, adaptive classification, and concept drift. And this is for further reading and assignment ideas. And what is natural language processing? NLP. Just 2 minutes, guys. So, natural language processing. What is NLP? Natural language processing (NLP) is a branch of artificial intelligence (AI) that gives computers the ability to understand, interpret, and generate human language. Think of it as a bridge between human communication and computer understanding. The ultimate goal of NLP is to enable seamless interaction between human and machines using natural language, just like uh, we communicate with each other. And core challenges ambiguity. Human language is complex, nuanced, and highly ambiguous. This is the fundamental challenges NLP seeks to overcome. Consider the sentence: I saw a man on a hill with a telescope. This sentence is ambiguous. Who has the telescope? Did I use the telescope to see the man, or was the man on the hill holding a telescope? A human might use context to figure it out, but a computer needs to be explicitly taught how to handle such ambiguous. Uh, the two main components of NLP tasks are often divided into two main categories: natural language understanding (NLU) and natural language generation. This is the natural language understanding. NLU is this is the reading part. NLU is about comprehending the meaning of text or speech. It is a harder task because it involves dealing with inherent ambiguity of language. Examples: identifying the sentiment of product review, positive negative, determining the topic of the new articles, extracting key information from the legal document. Natural language generation, this is the writing part. NLG is about creating meaningful and coherent phrases and sentences in human languages from structured data or ideas. So example, or like a weather app generating summary, like it will be sunny with a high of 75 degree Fahrenheit, and AI writing a news article from sports statistics, or chatbot formulating a response to a user questions. How does NLP works? A layered approach like pre-processing, tokenization, text cleaning, normalization, and feature engineering, and uh, and modeling and analysis, and common applications of NLPs. So evolution of NLP, a brief timeline. So that's all about, and we are at the end of Module 6. Thank you all.